Welcome to the MongoDB Podcast Live. I'm your host today, Jesse Hall. We have an amazing live stream lined up for you. We're going to talk about scaling MongoDB without breaking the bank. So we have some new elasticity features that enable cost optimization without sacrificing performance. So if you're a developer, we're going to get into some more technical details. So stick around for that. And maybe if you're not as technology savvy, or maybe you're not as technical, maybe you're an ITDM, a decision maker, stick around too, because we're going to help you understand why you should choose MongoDB as your data platform. Without further ado, let's go ahead and bring on our guests today. We have Rob from engineering, and we have Alec from product. So welcome. Maybe let's just go through some quick introductions. Alec, would you like to introduce yourself first?
Absolutely. Thank you, Jesse. I'm Alec, product manager for Atlas clusters in MongoDB, focused on scalability, availability, and geographical expansion, and I'm based in New York City.
Nice. And Rob?
Yeah, definitely. I'm Rob. I'm a software engineer on the Atlas clusters team. Focus area overlaps a lot with Alec, focusing a lot on performance and scalability of Atlas clusters, and also based in New York City.
Nice. So we're going to talk about how we scale MongoDB Atlas, and we talk about elasticity. Like we didn't talk about this beforehand, but would one of you like to high level explain what is platform elasticity?
Yeah, absolutely. Thanks, Jesse, for the question. So something that we've observed a lot over the last few years is that cost optimization is sort of top of mind for companies of all sizes. And the way they think about it, generally speaking, is about balancing availability, performance, and budget constraints. And that's mission critical for them. We spoke with tens of Atlas customers across the board, from small startups all the way to Fortune 500 companies, to understand their elasticity needs. If you manage large-scale infrastructure, maybe you do, maybe someone you work with does, one of your top areas of focus is probably maximizing that availability and performance without increasing cost. And that trade-off is where elasticity comes in. And elasticity is sort of the property of the database or data layer that allows you to reach for maximum availability and performance without breaking the bank. And generally speaking, it's a really hard engineering problem and generally seen as a tough trade-off. And as developers, I'm sure you're aware, your number one goal is managing complexity, right? And so this is where Atlas really shines, because we believe we can provide you with the greatest elasticity so that we can take care of that hard engineering problem. You can reach for maximum performance and availability without breaking the bank, so you can have the cake and eat it too, effectively.
Nice. So let's bring this back a little bit. Like, help me to picture this in my mind. What, in like a real world, what does elasticity mean?
Yeah. So, for example, let's say you have an e-commerce workload. Let's say you're a small shop selling, let's say, some handmade items, and you see a lot of traffic throughout business hours, because let's say it's a local shop that sells only in your time zone, and you see a lot of traffic from 8 a.m. through 7 p.m., but outside of those hours, it's very quiet, right? You probably don't want to provision for maximum capacity for when it's the busiest. You want to see both your application tier and your data tier change the provision capacity as the actual needs change, right? And that's daily, weekly, monthly, annually.
Nice. And so why should that really even matter?
Because fundamentally today, your ability to do well as a business is determined by your cost structure and also by being able to compete globally, right? And so as the workloads change, as you introduce new features, as you sell more items, for example, for your business, you want to be able to continuously adapt to those changes in demand effectively, right? You, as a developer, want to be able to build things for your users such that you can serve your users better. You don't want to worry about all the non-functional things that are happening behind the scenes. You want to sort of make your do whatever it takes to make your beer taste better, rather than
Mhm.
focus on, sort of something that we as a database provider can do a great job at.
Yeah, personally, I hate having to deal with all that stuff. That's why I love that Atlas just does it, most of it for me. So, yeah, so I feel like Mongo or Atlas has always been elastic, right? But what have we done to like increase its elasticity?
Yeah, absolutely. So first of all, if you are developing a new application, perhaps you've already started in the cloud. If you are developing an existing application, perhaps you're considering the move to the cloud. Well, you might be aware that the key tenet of the cloud is that it packages elasticity in a simple interface and makes it easy for you to consume, right? So it's one of the key value propositions of the cloud.
Mhm.
Now, Atlas has always been elastic, right? As you mentioned, Jesse. But now what we see is we are able to actually vertically scale the database, the dedicated Atlas clusters, up to 50% faster.
Mhm.
And what that means is we can complete a scaling operation within single digit minutes. And that's a huge deal, because if you have a huge workload during certain hours, that ability to change that provision capacity quickly is mission critical for you to retain that availability and performance and serve your users productively. Now, the great thing about what we've done here behind the scenes is that this requires no configuration changes on your end. So yesterday, Atlas took a while to scale up. Today, it takes less than 10 minutes. And that just works out of the box. It just happened behind the scenes. And you get the benefit of a continuously improving database as time goes on.
Nice, nice. So is this we talk about like enterprises versus startups, like where does this really apply? Like I can understand like startups kind of scale slowly, but enterprises there might be a lot of fluctuations. Like how does this apply to different use cases?
Yeah, so the great news is that this is a fundamental property of our architecture and the database and the data platform, i.e. Atlas. And therefore, this applies across all sorts of workloads. So all the way through small M10 clusters that you deploy for development purposes, all the
Mm,
way through production clusters with tens of shards on an M200 NVMe cluster, right? So those improvements to elasticity are sort of across the board, and uh, in a high volatility environment like we currently have, or perhaps for your specific use case, that data tier elasticity is priceless, right? So
yeah.
so we believe we can help you grow and scale on Atlas and make your workload elastic day to day as well.
Yeah, nice. So we talked a little bit about that e-commerce example. Let's maybe dive a little bit deeper into that example. How can this new these new improvements help that platform specifically? If we're talking about e-commerce as an example.
Yeah, absolutely. E-commerce is a really interesting vertical because folks that are very familiar with the space, I think, will probably be nodding very actively right now. But it's a very challenging environment because the sector is ultra competitive, right?
Mhm.
And what that means is, if you operate an e-commerce or retail outpost, you need maximum levels of elasticity, because you need maximum of performance and availability when that demand increases.
Mhm.
But you're also in a very competitive environment. Therefore, your cost structure has to be maximally optimized, right? So you cannot afford to remain over provisioned for peak workload. Like the ability to right size your workload is your competitive advantage, effectively, in your area. And so, for example, with the recent changes we've made to Atlas, a large customer in the food delivery industry that frequently launches promotions and notifies customers of those promotions um, has observed that this can cause a huge spike of traffic to their clusters. Now they trust Atlas so they can resize that cluster ahead of time in under 10 minutes, which helps them realize cost savings, because
Mhm.
they can stay on the lower tier when need be and only scale up when desired. And that ensures that they can effectively manage and develop their delivery experience for their customers. So they don't have to actively manage the database. They can effectively focus on what makes their beer taste better, which in this case is serving their end customers across the board.
Yeah. So for the IT decision makers out there, what can they learn from these customers and how they are provisioning these assets?
For sure. I mean, so first of all, the Atlas brings to bear the fruit of the cloud. So it allows you as the decision maker to effectively trust Atlas to make that elasticity management problem go away and focus on other operations that are critical to your IT infrastructure and computer infrastructure, such as the
Nice.
application tier, your business logic, etc.
Yeah. In this example specifically, I always think of Black Friday. So like you don't want to miss out on any sales. You want to make sure that you've got enough provision. But then weeks later, you don't want to stay at that same tier. You want to come back down. So yeah, these features, I can see how they definitely come into play. Let's was there anything else in the specific example that we wanted to call out? I think we covered all of those parts.
Perhaps I would also add
Yeah.
that to my earlier point, that because this works across the board, i.e. across both small clusters as well as clusters, tens of thousands of tens of shards, thousands of nodes. If it's a mission critical workload that scale, we on Atlas can very effectively handle that scale and be able to give you that provision resources all the way from when you start as a business all the way through achieving critical mass and becoming a sort of a Fortune 500 corporation.
Yeah. Yeah, that's kind of been the thing that MongoDB has always been really great at, is scale. That's really what it was built for, is scale, right?
Absolutely.
Yeah. Well, let's dive a little bit into some of the specifics and these new features and how they work. And the first thing that we'll kind of dive into is the faster primary upscaling. Rob, do you want to touch on that point? And I think we're going to talk maybe a little about some details, and then in a bit we're going to see some things in action as well. So the viewers out there, stick around. We're going to actually show some stuff. That's not going to be just telling. We're going to do some show and tell. So yeah, Rob, if you want to talk about some of these key things that we've implemented.
Yeah, definitely. And I think kind of going to tie this back to some of Alex's points earlier. So the basic idea of this faster primary upscaling feature is that you're going to kind of have two main types of workloads against your clusters: read workloads and write workloads. In cases where you have write workloads, it's kind of tougher to scale those, because for read workloads, you can scale out to secondary nodes. For a write workload, it's going to be dependent on the primary. And the idea of faster primary upscaling is that if you have these write-heavy workloads that need more write throughput, we can move when we have a primary node for your cluster on more powerful hardware earlier on in the scaling process. So in addition to bringing down the time for scaling clusters, we've also brought down the time from you starting to scale a cluster to you seeing more throughput for writes by even greater degree. Because before, we'd be scaling the nodes, and it's pretty likely that the primary would change when we were almost done with scaling. With the faster primary upscaling feature, we've kind of switched that ordering a bit, where it's pretty likely that the first node that's scaled is going to be the new primary. So if you're in a write-constrained workload, or you're seeing things like high CPU usage on your primary, operation times increasing for writes, any of that stuff that Atlas is also going to be alerting you to, you can start scaling, and you're going to see relief in like 2 or 3 minutes, instead of the amount of time it takes for the full cluster scaling.
That's nice. I've heard of this thing called front loading the primary. What, for a layman, like what does that mean, front loading the primary?
Yeah, definitely. So a key part of the MongoDB ecosystem is its robustness and ability to handle bad situations or situations where something's going wrong. And we kind of leverage that when scaling, where we can take down one of those nodes of the cluster, and the ecosystem is responsive to that, to your consumers, your clients. There's nothing obvious to them with the infrastructure and tooling we have in place to handle servers going down and things like that. And part of that existing ecosystem around MongoDB lets us ask for this upscaled node. We can kind of say, hey, this node is probably better for being primary. And then the MongoDB database can handle all the stuff behind the scenes that goes into making that node primary. And there is a lot that goes into it behind the scenes, both on the database side and the client side. But the big advantage of Atlas or MongoDB is that as a consumer of it, you don't really have to worry about that. It's on us to handle all that complexity. And you can have a simple interface to your cluster and the scaling behavior where you can scale on demand and get relief or decrease in cost quickly, either in cases where you're under provisioned or over provisioned.
Nice. So, and again, that's the reason. Like, I'm not a fan of self-hosting. just use Atlas because it does everything for you. It just makes your life so much easier. So we talked about the primary upscaling. What about replica sets?
Yeah, definitely. So there's kind of a mix of advantages here. So if you have a workload that has secondary reads, you can have in Atlas like read-only or analytics nodes. And one optimization we've made here is allowing those nodes to scale in parallel. So if you have a primary or write-heavy workload, this isn't going to benefit you as much. But if you're leveraging secondary reads, this can be a huge benefit. Whereas before, we would be taking one node down at a time and the scaling procedure. And it was very safe and it worked pretty good. But the downside was that if you had these secondary read workloads where you had to read a lot of data and you were leveraging your read-only or analytics nodes, there'd be more time spent in the scaling procedure than was strictly necessary.
Mm-hmm.
And the idea here is pretty simple. If you have such a configuration, we allow you, and now by default, start to scale those nodes in parallel. So you can have much faster upscaling of those secondary nodes and more throughput for reads on your cluster than was possible before.
Nice. And so the other thing is auto scaling. Do you want to walk through the demo now, or maybe like I guess let's talk about the auto scaling, the features, and then we can look at the demo in just a minute. I think we had a couple more points here.
Yeah, definitely. I think auto scaling is another big win for Atlas. In the demo, we're going to be showing off manual scaling, but it is in a situation where auto scaling would have kicked in were it enabled. The basic idea of auto scaling is that for a lot of workloads, you can enable auto scaling in Atlas, and in cases where you're seeing a workload increase or a workload steadily decrease, Atlas can kind of manage the elasticity of your cluster for you. So if you're experiencing an increase in traffic or a decrease in your cluster performance from a workload that's increasing, Atlas can automatically scale up your cluster. And if that workload has subsided and we now know it's safe to downscale your cluster, we can downscale your cluster so you leverage cost savings from not needing all of the resources that you needed, an hour or two ago.
Yeah. Is there a situation where I would not want to rely on auto scaling? It just seems like, again, I love that Atlas just does so much for me, and it seems like a no-brainer to just enable auto scaling if I know that there could be some fluctuations. Is there a reason why we wouldn't do that?
Maybe I can speak to that.
Yeah.
So it's a great question. We believe for 95% of situations, the Atlas autoscaler for cluster tier scaling will fulfill your needs. And that's all the way from moderately spiky workloads all the way to very sort of slow seasonal increases, right? As your workload ramps up because your business is doing better. There are certain edge cases in which we believe some sort of custom configuration might be worthwhile, but we see that very rarely in practice. And we believe that long term, these edge cases in Elasticity is still something we want Atlas to be able to handle.
Yeah, that's what I assumed. So thank you for clarifying that. So talking specifically about DevOps teams and ITDMs, decision makers, they're thinking about cost, operational overhead. How does parallel scaling factor into that?
Yeah, so I think it kind of combines two big things. One is the fact that a lot of your workloads don't need the data that's absolutely the most up to date. And this is a huge opportunity for cost savings, where you can leverage MongoDB features like the read preference to say, hey, for this workload, it's okay if my data is a little bit out of date. There are ways you can configure, the limits as to how out of date it can be. But if you're okay with this data being 500 milliseconds or a second old, it's much easier to scale up the ability to read that data than it is to have data that is absolutely the most up to date. And by leveraging this feature, you get to use the resources that are provisioned that exist for durability and availability that also can provide performance. So in a MongoDB cluster, you're guaranteed to have the secondary nodes. And with the secondary read preference, we'll start to have operations that are read-only going to those nodes. So we're leveraging their compute resources and I/O resources to serve your business needs, in addition to the critical functionality that they serve as providing availability and durability for your cluster as a whole. Atlas also has some features that extend this for more sophisticated use cases, or use cases where you really have a higher volume read workload. And we allow that through read-only nodes and analytics nodes. And those nodes are nodes we expect you to use for read-only workloads. They're similar in behavior to one another, but one very nice feature of analytics nodes is that you can also scale those independently. So if you have like a lower volume workload or a workload that is not time critical in nature, where you can work on a little bit out of date data, analytics nodes can be a huge cost savings if you have some read workload where you're okay with that happening at a pretty low rate, or alternatively, if you need that to be at a higher rate. Either situation Atlas can handle, and you can configure the hardware and resources for that analytics tier separately from the resources for the electable tier that serve the base cluster functionality.
Yeah. So kind of when it comes back to it, it's always about your use case or your access patterns, your query patterns. That's how you model your data. That's how you scale your data. All has to do with how you're accessing your data. That's one of the critical things when I'm talking with developers is helping them understand when modeling your schema, when designing how you're going to scale your database. It's all about your access patterns. Whereas, coming from the relational background, it's always, there's just one way to do things in the relational world. It's very rigid. In MongoDB, there's many ways, and it's easier to scale and do all these things because of the flexibility that we have. So it's amazing. Let's go into the demo part now. Let's get a walkthrough of some behind the scenes of what we built and how it works, and see the user interface and all of that. Rob, let me know when it's safe to share your screen. Oh, and you're muted as well.
All right, it should be good when I've got the tab up here.
Gotcha. All right, so we'll go ahead and share your screen. Awesome. So walk us through this. What are we looking at?
So this is for the purpose of being able to jump back and forth. We've got a recording of this.
Okay.
So right now what I've got up is an example of a cluster that has a write workload where the cluster is a little bit constrained. So we can see that the execution time, and this is in the Atlas metrics UI, we can see the execution time for writes is a little bit high, and we're around 10,000 operations per second. And I'm going to go through the process that you would do to scale up this cluster. Fast forwarding through some of this a little bit. So the way that you can do this in the Atlas UI is we have a lovely cluster editor that allows users to change the tier of their cluster. Let me zoom out a little bit here. So I'm going through and I'm saying, hey, I want to have the base tier for this cluster that manages the write workload and the non-analytics read workload, and I want it to get scaled up. And I'm going to fast forward through the scaling process here. The main thing that I want to call out is the time that has elapsed. So it's going to be a little over 2 minutes for us to see this change. And the thing to call out is the kind of order of events that happens here. So this is an example of the faster primary upscaling feature, where this node over here was our original primary, and we saw pretty high, or relatively high, operation execution times and high CPU usage. That's not on the graphs here. And we had around 10,000 operations per second. After the first node here got upscaled, the faster primary upscaling feature resulted in it becoming the new primary. We saw about a 75 or 50% reduction in operation execution times, and the throughput increased enough that it went off the graph here. So even though this cluster is still in the process of upscaling, and we're going to get to more powerful hardware on the other electable nodes in this cluster, pretty early on in the scaling process, we're at a point where your ability to handle write workloads or primary read workloads is massively increased pretty early on. So if you were in a resource-constrained scenario where the scaling was, as a result, or triggered due to, an increasing volume of operations from your users, you're having a quicker time to having the resources that you need be in alignment on your Atlas cluster, allowing you to better respond to sudden increases in demand, or just in cases where you're, scaling your cluster, having the upsides of that upscaling happen earlier on in the process.
Nice. So before we continue, what was it like before we implemented these changes? So you're talking about this happened in about 2 minutes. What was the situation beforehand?
Yeah, definitely. The overall picture is going to be pretty similar. I don't have the full timeline here in the video, but you can imagine that instead of this node here getting upscaled and becoming primary, we'd have this node get upscaled, this node get upscaled, and then the original primary would get upscaled. And at the time the original primary gets upscaled, one of these two nodes would likely win, or would win the election for primary, and then you'd have more resources. So we've bumped up the time to relief, or time to having more powerful hardware that is in use by the primary by a significant amount of time for our users.
Nice. So let's talk about the engineering effort that was involved here. How could your team tackle this and make this happen without risking any like uptime issues?
Yeah, definitely. And I think for our team, like the Atlas team, a lot of the great functionality of MongoDB made it a lot easier for us, in that there's a lot of robustness and availability and durability built into the core database product. For us, the biggest concern, of course, was making sure that this feature had a positive impact on our users. And a lot of the internal tools and reporting allowed us to make sure that the feature was having a positive impact on our users. Um, I think for the engineering work that went into this, um, I think the biggest one of the biggest points here was just the testing and making sure that the behavior of Atlas clusters here was matching our expectations, and ensuring that when we're making these changes in some adverse scenarios where the cluster's under load, that things are still working as expected.
Hmm. Yeah, that's awesome. So, like, just because of the distributed nature of the environment here, um, there's bound to be some bottlenecks. Can you talk about some instrumentation that um, was used to identify any potential bottlenecks?
Yeah, definitely. I think the one of the coolest things about Atlas is how platform agnostic it is. So, you can have a mix of cloud providers, regions, all that stuff. And that's great for you as an end user, but it does add some significant complexity for the engineering team, and that we've got to support a lot of different environments and a lot of ways those environments can behave. So part of the optimization work that went into our improvements was increasing the visibility that we have into what's going on from a user saying, hey, we want our cluster to be more powerful. And every step in that process, seeing where we could optimize stuff to eke out a little bit or reduce the time it takes for one step in the process by a little bit. And that stuff can add up over time. Um, there's a lot of industry, or maybe not industry standard, but ways of like tracing events through distributed systems that we leveraged. And that was very useful for, being able to see where we had optimization opportunities and could have a few quick wins that were smaller in impact than any of these bigger features that are kind of user facing, like faster primary upscaling or
Hmm.
parallel node type scaling, but definitely add up and reduce the time it takes to scale by a little bit as well.
Yeah. And so, like, this sound to me like this seems dangerous. like what kind of safety checks are there in place to like make sure that something doesn't blow up, the clusters destabilized, etc.
Yeah, definitely. So I think, again, there's a lot of safety checks in MongoDB itself. So there's a lot of ability of the core database product to handle situations like, oh, this node has suddenly gone offline.
Mm-hmm.
Um, Atlas, we don't randomly pull out nodes offline. We're much more conscientious and cautious. So I think the main point of safety is that we operate on Atlas clusters in a very methodical manner, um, where even with the most aggressive scaling option for parallel scaling, we're still being very careful with the electable nodes of a cluster and making sure that we're leaving the cluster in a good state at each point in the scaling operation. Um, so there's a lot of health checks on the Atlas side where we can see the view or the state of an Atlas cluster and make sure that us operating on a node to scale it up isn't going to destabilize the cluster. Um, and this is of uh, utmost concern for your electable tier, because there, it's very important, or uh, very important that the primary election process can go as smoothly as possible if there
Hmm.
is a primary change. So making sure that there isn't replication lag when we're scaling, and being methodical about what nodes that we scale is an important part of that process, as well as ensuring that the uh, conditions are good for a new primary getting elected when a node gets scaled. And I think a lot of this is kind of um, a lot of this existed before any of the changes we've made. It's been baked into Atlas as a product. And we have some additional safety checks or additional safety with some of the faster primary upscaling, where the server has the opportunity to decline to have this new node become primary immediately. So if it has to catch up on the auth log or something, it can do that and then initiate a priority takeover to become primary. So there's some additional safety there as well.
Nice. Back to the point of I'm just glad Atlas does it all for me because I wouldn't know where to start. So amazing improvements as well. Was there anything else that you wanted to show, or can I take your screen down?
Oh yeah, definitely.
Yeah. Okay. All right. I'll make sure we covered all of that. Let's talk now about like some key, I guess takeaways or like next steps or like let's talk directly to the engineers. Like, so what does this mean for an engineer? What is like the real world impact, I guess?
Yeah, absolutely. I'm happy to take that. So yeah, if you're an engineer or a DevOps person or some other type of operator, well, faster and more elastic database scaling means fewer manual interventions for you and your team. I mean, and that just unlocks so much more productive time for other things. It means we can potentially, depending on your workload, take that elasticity and scaling completely sort of in-house into Atlas, and you can just sort of set it and forget it. That's our goal for most situations. That also means your analytics tiers can scale more robustly, right? And something that Rob mentioned is that the analytics tier is a great opportunity for cost savings because you can independently configure the cluster tier there. And very often your analytics tier or analytics workloads is not nearly as time sensitive as your operational workload. So at the high level, the TLDR is that you can sort of delegate this complexity of scaling to Atlas and essentially focus on making your product better for your end users.
Nice. And so what about for like the directors, the ITDMs, the CIOs, like what's the ROI? Lots of acronyms there. What's the return on investment?
Absolutely. Yeah, that's a great question. So it's a combination of, first of all, it's better cost optimization and performance. And in this environment, that's always top of mind. Obviously, increased availability. I think as the years rolled on, that level of availability where customers essentially can always access your product has only increased. So that goes without saying that this is, mission critical for you as an ITDM. And then lastly, faster time to market, right? Because if you no longer have to manage elasticity, but we can do it instead, you unlock all these resources to build the next generation of your product, to integrate perhaps some AI features into your product, or maybe focus on just improving user experience.
Nice. And for those who want to learn more and they want to dig into these features, there are some docs that are linked in the video description. There's some that are talking about the configuring scaling mode, configuring auto scaling, and setting read preferences. So be sure to check out those links and those docs to learn more about this. What are some key takeaways from each of you that you want to convey to our audience?
Maybe I'll take it first.
Yeah.
So I would say from my point of view that we have invested a ton of effort in the last 18 months into sort of platform elasticity and cluster elasticity in particular, and that applies to both manual scaling and auto scaling to bring that level of availability and performance to your workload. And we're sort of only just getting started. We have a very long roadmap to continue iterating and bringing more opportunity for you to hand over that complexity to Atlas.
Nice. What has been your experience in making these updates and these changes, Rob?
Yeah, I think it's really exciting and interesting being able to work on these distributed systems and figuring out how we can find ways to make your experience of using Atlas faster while still maintaining our kind of mission critical promises of availability and durability. I think I also learned a lot about some of the pretty cool MongoDB features, especially around like secondary reads and how you can target, workloads that might be important but not reliant on super up-to-date data, which I think is a really cool experience, or a really cool feature for our analytics tier, especially with the parallel workload scaling. We can have really reactive changes to those nodes for your read workloads.
It is amazing. Every time I talk to developers, how many features there are in MongoDB, and I literally learn something new every day almost. And also how many developers don't know about all of the features that we have, and so especially in Atlas, there's so many things under the hood that you kind of take for granted. And so it's amazing that we have such great teams, engineering teams, working on these things and continuing to improve them. Of course, we're going to continue to improve over time as well. But these are amazing, amazing things, and really appreciate. We have a quick question here. It's not really related, but we have a question here on LinkedIn, and I want to answer it. How does MongoDB Atlas have, or does MongoDB Atlas have a Kubernetes operator and to deploy to K's platform? The answer is definitely yes. Just go check out our docs. Go to the MongoDB docs. There is a great documentation on how to actually set that up. Anything to add on that from either of you? No? Yeah, the answer is yes. Go do it. You can do it for sure.
Yeah, we're happy users of that internally, I'll say.
Oh, for sure. Yes. Amazing. All right. So we've covered all of this, all the topics here, I think. Any last words before we go to our audience on this topic? Go use it.
Exactly. Absolutely. I mean, as I mentioned, we continue to build improved elasticity for the platform, and I totally encourage you to check it out, what we've built, and it was a very fun conversation.
Yes.
Yeah,
awesome. Amazing. Thank you both for being on. Whenever you finish the next great feature, we'll have you on again. So really appreciate it. And audience, remember, tune in every week, Tuesdays, Thursdays, we live stream various topics. So keep an eye on YouTube or LinkedIn, wherever you're at. So we'll see you next time. Thank you.
Thank you, Jesse.